Graph each of the conic sections. So there's three possible conic sections. When it's got x squared minus y squared, that's a hyperbola. When it's got an x squared plus a y squared, that's an ellipse. So this one is an ellipse. First of all, the center, this one is not centered at the origin because of this information right here, that plus 2 on the x, is actually shifting it to the left. Since there's no extra information on y, then that's just 0. And then what we'll do is have it centered at negative 2 comma 0. And then you take a look at this. Because this is attached to the x, this is going to be x information, or in other words, left and right. So you take the square root of this, which is 4, and go to the left and the right by 4. So if I go to the right by 4, I would end up at 2. And if I go to the left by 4, I would end up at negative 6. Okay, so those are part of the ellipse. Then for the y information, or in other words, go up and down, take the square root of this number, that's a 5. So you need to go from the center, go up by 5, and go down by 5. And then just make a nice ellipse. If it's drawn perfectly, it's going to look a little bit taller than it is wide. Mine's not perfect, but close enough. Okay. So by labeling all the important points, I'm talking about from here, here, here. You can actually label the points, but you can see that this one is at negative 2, 5. As long as you're able to see where those points are, that's good enough. And for this one, it is a hyperbola. And a hyperbola, in order to graph that, well, like we had over here, we had to take the square root of the number underneath. Well, with this one, we could say the numbers underneath are 1s. So, what you do is, well, first of all, this one is centered at 0, 0, because there's no x minus something or y plus something to change that. You then take the square root of this number, which is going to be a 1, and because that's underneath x, go left and right by 1. Then do the same thing here, which is going to send it up and down by 1. And then what you do is, basically this makes a box, which you could draw, or you could just visualize the box. And if you take the corners of the box, I'm just doing this in pencil because this helps you draw the graph, but it's not actually the hyperbola itself. And then once you've done that, then draw a line connecting the corners of the box, no, in other words, the diagonal, but it's going to be an asymptote, so you draw it as a dotted line. And then this one, okay, now with the hyperbola, it's going to get closer and closer and closer to the dotted lines, but never actually touch or cross the dotted line. The only question is, does this one open on the x-axis, or does it open up and down on the y-axis? Well, it's whichever one is positive. The one that's positive, that's the direction it's going. So it's going in the x direction, or in other words, the x-axis. So it's going to touch right here at 1, and then it's going to get closer and closer to that asymptote. So it's going to be a fairly wide hyperbola. And just do the same thing for the other branch of it, it's called, the two branches. There's the hyperbola.